Welcome to Lesson 3, Part 2 on Exponents. In this section, we will take a very basic and introductory look at what exponents are and how they're valuable in math. Let's first think about a definition. An exponent is essentially a way to show repeated multiplication. That's multiplication of the same type over and over and over again. With every exponent, there is a base and there is a power. It's written as the base number raised to some power, which is usually another number. So we're going to think about this. We think 2 to the power 5 is how you might say a number that has an exponent. And it basically means that we have 2 times 2 times 2 times 2 times 2. 2 being multiplied by itself 5 times. So let's think about the notation. Let's think about how we write it. Let's go back and look at the example we just talked about. 2 times 2 times 2 times 2 times 2. We don't always want to say that, so we say 2 to the power 5, 2 raised to the power 5. This little caret symbol means being raised to the power. So how else do we write it? What are some other examples? 3 to the power 4. What does that mean? It means 3 being multiplied by itself 4 times. 3 times 3 times 3 times 3. If I switch the numbers around, it will mean something different. So let's think about saying 4 to the power 3. Well, it means I'm going to have 4 times 4 times 4. 4 being multiplied by itself 3 times. You see how even just the most subtle differences will give us a completely different type of problem and, of course, a different type of answer. Let's think about a quick example about germs and how germs grow. In a basic experiment, people want to figure out how quickly germs are growing in a laboratory setting. On day 0, we might start off with 1 germ. 2 to the power 0 is going to be 1. This always actually is the case. Anything to the power 0 is 1. But let's move forward with this current example. On the very first day, we can write 2 to the power 1, which is going to be 2 just by itself, which equals 2. So on the first day, our one little germ multiplied and ended up making 2 germs. So what happens on day 2? And we're going to identify a pattern here shortly. On day 2, we have 2 to the power 2, which equals 2 times 2, and 2 times 2 is 4. So on the second day, we end up with 4 germs. What about the third day? On day 3, we have 2 to the power 3. That's 2 times 2, which is 8. 2 times 2 is 4, times another 2 is 8. So on the third day, we have 8 germs. Let's keep going. 2 to the power 4, 2 times 2 times 2 times 2, which equals 16. 2 times 8 from the previous example is 16. What about day 5? And we can keep on going. 2 to the power 5, like we saw in the earlier example, 2 times 2 times 2 times 2 times 2 equals 32. Now, we don't always need to be able to write these things, but let's do it for the sake of practice. Let's imagine another example where we can use exponents. Let's think about ants growing in population in an ant farm. So I'm going to example 2. What about 5 to the power 3? 5 times 5 times 5. So how would I work this out? Well, the first 5 times 5 gives us a 25, and then we multiply that again by 5, and our final answer here is 125. So 5 to the power 3 is 125. Now, in these situations where our numbers can get rather large, we do have the ability to use calculators. But let's take a look at another example of how we would do this on paper. Let's take a look at 3 to the power 6. We're going to multiply 3 by itself 6 times. 3 times 3 times 3 times 3. You get the idea. Well, our first 3 times 3 is going to be 9, multiplied by 3 again. This will give us 27. Multiply this by 3 again. Again, our numbers are getting kind of big. This time we get 81. Multiplying this by 3 a fifth time. And in this case, the 3 times the 1, the 3 times the 8 gives us 243. And we look to multiply this by 3 one final time. And our final answer here is 729. So yes, our numbers do get rather big. A lot of times calculators are recommended for work with exponents, but we can at least show you the basic breakdown and understand at least what it is. So what does it connect to? Exponents can help us understand population growth, whether it's germs, ants, or even people. Exponents can help us understand how money grows and even help us count the large amount of stars in a galaxy.